Welcome back, students. We will continue practicing the problems on trigonometric identities. So we are presently here practicing the problems for sample and board problems for trigonometric identities. So if you are directly come to this video, kindly check part 9, 10 and 11 for the theory part of this video and the reasoning behind these formulas, the different formats. Practice those three videos, write and practice those formulas in those videos before coming to this video. So the three main identities which we will be using in these problems or forthcoming problems are this one identity based on sine and cos, the other one based on tan and sec, and the third one on cot and sec, cosec. The first problem is they are given sec theta plus tan theta is equal to p. Then what is the value of tan theta? So they are given some four options. When you look at this, if you have checked video 10 properly, you will understand this is related to trigonometric identity 2, which says that sec square theta minus tan square theta is equal to 1. The sec square theta minus tan square theta, you can treat it as a square minus b square, which is equal to a plus b into a minus b. So I am splitting this equation as two forms, sec theta plus tan theta into sec theta minus tan theta equal to 1. Since the problem gives the value of p, you need to substitute the value of p here. So value of p is equal to sec theta minus tan theta is equal to 1. So you can now find the value of sec theta minus tan theta is equal to 1 by p, which is basically the inverse of sec theta plus tan theta. But you need the value of tan theta to be calculated. So you have two equations in your hand now. One is sec theta plus tan theta is equal to p. The other one is sec theta minus tan theta is equal to 1 by p. So you can algebraically solve this to find out the value of tan theta. How? You need to eliminate the sec theta here and in this equation, which can be done when you subtract both these equations. When you subtract both these equations, sec theta plus tan theta minus the whole of sec theta minus tan theta equal to p minus 1 by p. Okay, when you subtract it, the sec gets cancelled and you have 2 tan theta on the left hand side. 2 tan theta is equal to, you are going to take the LCM and you are going to add it. P into p is p square minus 1 divided by p. So 2 tan theta is equal to p square minus 1 by p. So tan theta is equal to p square minus 1 divided by 2p. So this is option B. So option B is the right answer. Then the second problem is 2 sine squared a minus cos square a is equal to 2. So what is the value of this angle A? That is the problem. See how to approach this. You know the relation between sine and cos. So you can convert the equation to one of the other forms. So like you can convert sine to cos or you can convert cos to sine. Solve it and you can find out the answer. So what I'm going to do is, in the place of cos square theta, this is trigonometric identity 1. In place of cos square theta, I'm going to substitute 1 minus sine square theta. 2 sine square a minus 1 minus 2 sine square a equal to 2. This 2 sine square a becomes added like 1 minus minus into minus plus. So it becomes 3 sine square a equal to, this 1 goes to the other side, minus 1 goes to the other side, it becomes 2 plus 1 is equal to 3. 3 sine square a is equal to 3. So sine square a is equal to 1. Square root of, we are going to make square root on both the sides. So sine a equal to 1. So what is the angle for which the sine value is at 1? Value of angle or the angle is 90 degrees. So the answer A is 90 degrees. Second option is the right answer. So basically in this problem you see a mix of trigonometric identities as well as the angles, specific values at specific angles. So it's a mix of both the concepts. Now problem 3. Now the equation look big. No worries, it's quite for simple and straightforward. A cos theta plus b sin theta is equal to m, and a sin theta minus b cos theta is equal to n. So they are asking us to prove a square plus b square is equal to m square plus n square. So how you are supposed to do is, you have to first find the value of m square, n square, then add both. When you add both, you should get a square plus b square on the other side of the equation. So let us do that. M square. So m, I'm going to square it. This is nothing but treat the whole equation. This as a and this was b. A plus b whole square is equal to a square plus b square plus 2ab. So I am going to expand that. M square is equal to a square cos square theta plus b square sin square theta plus 2ab sin theta into cos theta. The same way, I am going to do it for n. So n square is equal to, now remember it is not a plus b, it is a minus b. So a square sin square theta plus b square cos square theta minus 2ab sin theta into cos theta. So you have to add both these equations now. M square plus n square. M square plus n square is, you are going to add this one by one. A square cos square sin square theta cos square theta. Similarly b square sin square theta cos square theta. And these both gets cancelled because plus and minus 2ab sin theta cos theta, these both gets cancelled. So as per trigonometric identity, you know sin square plus cos square is equal to 1. So you're going to substitute 1 here as well as 1 here, which becomes a square plus b square. Thus, you have proved m square plus n square is equal to a square plus b square. So we have almost completed the problems on trigonometric identities. From the next video, we'll see more practice problems around the sample question papers which was released in 2026, as well as a few board problems across the trigonometric concepts. I will not restrict to angles, specific angles or trigonometric ratios or trigonometric identities. It will be across the entire chapter. Thank you and bye till then.